Hi, today I'm going to talk about convolutional neural network in R using Keras from Python. This is an example for image analysis. So Keras is an API from Python. To install the library, you might need to Google for instruction. There might be some issue for installing or loading the package. Make sure you have installed and loaded correctly for this package from Python. After the package, let's take a look how the image looks like. So this is how we read the image in R. So as you have all known that a picture is considered as a three-dimensional matrix with a height equal to 3 for RGB channels, and then each channels you have intensity for the pixels row by column. Okay, so now we have the function to read the image and also to display it. So now let's train our convolutional neural network. So first of all, we need to extract a feature, and we also need to resize the image since my training image have come in different size. So let's say I'm only looking to 150 by 150 pixel. So this will be a square image after my resize. And then I'm also kept, since this is an image of a 3D, so it has a depth of equal to 3. I'm going to make it into one dimensional, so which is to make a RGB, a color image, into only gray. It's only showing the intensity of the in gray color. So now I define the pixel for the pixel to the image size for feature extraction. Then I run this a function here to read the image, all the image from my training set. So I'm not going to run the code here. I already finished. I already store all the objects, and I already run all the codes. So if you based on your design, the code and the reading process can be very long based on your computer, and also based on your design of the convolutional neural network, it might also take a long time, like a couple hours to train, based on your own based on your network structure. So after reading both training set and testing set, and now you can also take a look to see what's the image look like after you extract the feature. And then another thing that is also important is that you need to resize and to transpose your data set, which is a flattened list from all the pictures. So basically, one image is a matrix, but by putting them into a list and then do a R bind, which I think it is in I probably included in the code. So after doing that, it is stretched out into a list or into a data set. So that data set is contain the matrix or the intensity of the pixels for all the image, rather than separate them into different elements. So all the data set become one. All the image are combined into one data set. So you need to redefine your dimension. So here you can see that the data set is have four dimension. So it's 4 dimension, and then you also need to reorder them in, so to make sure that your neural network can know how you want to start it to train your model. So now is the most important part for the structure of the model. So to run a convolutional neural network, first started a Keras model sequential. So you have to pre-start it. So this is how your first layer of first foundation. You need to start this model, and then here you can start it to design your structure. So this is a very short, a very simple structure here, but based for your need, you can always create a very difficult or a very deep convolutional neural network. So as you can see that I'm using a layer conv, and then for kernel size equal 3 by 3. So this is the size of the filter. So my filter size is that I'm using, so basically I'm using a 3 by 3 filters to to um, to to searching or to you can say to cover the image uh, a 3 by 3 pixel at a time, and then stride equal to 2, which is you move 2 pixel at each time when you move around in an image. Also for my first layer, I also have 128 filters, which each of them is a 3 by 3, and then I'm moving 2 pixel at a time, going to the right and then going to the second row and then the third row, and keep going on. And also here I also set the activation equal to ReLU, which is I think this is called Rectified Linear Unit. So basically this will help you to control some of the unit. So this function, it is defined as if a number is negative, then if the range for a number is negative, then y equal to 0. Otherwise, x equal to y. So that it will help you to it will help you to reduce the number of parameter for training, and it will also help you to it is also useful to reduce computate help you to increase efficiency, since a very deep convolutional neural network can be very difficult, can be computational expensive. And also for the padding is that so let's say so every time if you don't do this padding, your filter response will always be smaller based on your stride, and your filter will always be smaller than your original your original picture image. But if you do a paddling equal to same, basically just adding zeros to the boundary, so that after you do this future filter extraction, you will always get the same dimensional for your feature response. So these are the parameter that I input in this in my first layer. So after my first layer, I do a max pooling. So basically for a 2 by 2, so for my feature response, for a 2 by 2 matrix, I'm pooling the max number within a 2 by 2. So I think you should be very familiar how a convolutional neural network first how to use it first before you do the programming part. So and then I repeat twice feature extraction, max pooling again, and max pooling. So I do this 3 times, and I do a dropout rate about I drop out 1/4 of my third after my third layer, and then I flatten my bottom layer, and then after here I'm connecting to a fully connected neural network. So this part is help me to do the classification. So again, I have 50 units, 50 units in this layer. I also have ReLU for my activation. I do a dropout again. So all these is to help me to increase efficiency while I bring in additional filters or parameter to train. Also, stride can also help me to reduce to increase efficiency. And then for my last layer, I have one layer which is since I only have two category in my response in my categorical variable, and I'm using sigmoid function as my for the unit. So I think you should the code is very easy. Basically, just define what you need in the structure. But I would suggest that you read some paper to understand what a convolutional neural network is actually doing in terms of the structure and the algorithm and the formula. Then you apply. So after you design your model, and then you can use this compile function to guide your model. So now I'm looking for my loss function. I'm looking for binary cross entropy. So since I only have two categories for my image, is either a dog image or a cat image. So I'm using the binary cross entropy. And then optimizer, I'm using a function called Atom. So this is there are also other options you can choose here. So I think for Atom is another way for something called first order stochastic gradient descent. So basically, I'm using a gradient descent to minimize my loss function to improve my performance. But there are lots of methods to improve your performance. And then I'm looking for the metrics for to track my performance. I'm looking at the accuracy, so how accurate my model is doing. And then the last step to define to run this step is the step that to actually start the training process. So I'm using the fit function here, input my x and y data, and then I'm running the model 15 times. So this is something like similar to cross validation, and batch size equal to 20, which is I'm running 20 rows or 20 samples at a time. And then I'm running another 20. I'm using another 200 sample each time to train my data. Also, I have a validation split, which is saying that I'm using about 1/5 of I'm saving 1/5 of my training site for a validation purpose. So after you run this, so if it is a very difficult or a very complex structure, then it might take a couple hours to train. Since I already finished, so I can actually make the graph here. So as you can see, as my iteration increase, you can see that my loss is actually decreasing for both training and validation, which is about 1/5 of the training step. And you can see that my accuracy, which is what I'm trying to track, it is also increasing as I keep training my model. So now I can also predict. Uh, so I also have a testing set. So which is image without labeling. So now I'm using my model. I'm inputting image without label into this model, and then the model will tell me whether this is a cat image or a dog image. And then I can also get the prediction for the class for whether it is dog or cat, or basically 0 or 1. And then I can also get the probability for the prediction. So and then I can plot the image here. It might take some time to generate the graph. Okay, as you can see that it is color image, but after feature extraction, and I make it to a gray color, which is I remove the color channel. And then you can see that the image has this label here. And then so basically I'm just so these are unlabeled image, and then my model is saying like the first image is a cat, second image is dog, and then you can see that some of them are pretty good, and some of them you can see that it is making errors. So there are lots of things to adjust in your model to improve your accuracy. So this video is only to show you that you are able to do this, but not to show you like what's the well. There's never a best way to train the model. So and then you can also save your model as a R file. So the 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 core of this convolutional neural network is how you define your model structure here, so that you can whether increase your filter size or adding more filters, or make the stride maybe you can make stride equal to 1 by moving 1 pixel at a time to see more area, or to cover more more pixels when you train the data. And you can also use a different activation function for each unit. So using ReLU, you can probably always track. You can trap in the negative, always trap in the negative part. So maybe if one neuron is equal to 0, it might become inactivated if you're using ReLU, since if it is trapped in the negative region for the input value. And you can also change the pedaling to the same or valid, which means you are adding. If you whether you want to add a 0 to the boundary as a boundary for your image or not. And then you can also do max pooling. There are also different type of pooling, whether it is average pooling, median pooling, and also you can define the size, or whether you can just not doing max pooling. But just to let you know that by altering the method, the structure, or the filter size, or number of filters, the stripe, and all these activation paddling, you are adding more and more parameter for training. So even for something like this, there are probably like a couple million. There are already let's say about probably 4 or 5 million for this model here. If you were not doing the max pooling, or increase the stride, or not do paddling. So to make sure that the limitation of your machine, and also to make sure you understand what these numbers are stand for, then altering the structure, or to make it more complex to increase your performance, or and also understand whether you are doing the binary uh, categorical classification, or whether it is like something like regression, or there's also a multi-class cross entropy, and then other type of optimization method, and other type of metrics. And also you can change your iteration, number of iteration, batch size, and your validation split. So there are lots of parameter to alter in this model, but always make sure you understand what the convolutional neural network is doing, and how and whether your machine can handle, let's say, a 5 million parameter for training, or to increase the performance. So this video just to show you how to do it, but not like what's the how to improve performance. So thank you very much for watching, and you can always try to adjust or to alter the structure. So let me know if you have any question, and if you like the video, please subscribe and or to share the video. Thank you very much.